Welcome to another thrilling edition of Mathematics R Us. We're going to get you straightened away on some stuff today, so if you would take out your notes, I will share my screen. Take out your notes, please, under equations. Under equations. Can I say that any more slowly? Equations. I think you'll enjoy this. It doesn't really matter if you do, but under equations, and you will be excited about our little subtopic here, which is multi-step. Multi-step equations, which simply means it's going to take more than one step to solve. More than one step to solve. And it might be helpful if we just go back and do a quick little review here, children. You know, with equations, there are only four types of equations. There is an addition equation. There is a subtraction equation. There is a multiplication equation. And there is division equation. X divided by 4 is 8. Okay? And if you remember, boys and girls, the fundamental rules are just simply, you want to get the letter by itself, you just think opposite. You think opposite. And what you do to one side, you do to the other. Do thou to both. So quickly, let me just review this. So, you know, if it's an addition equation, you're just going to do the opposite of that, which is subtract. And you just have to do that same thing to both sides. And I need to see that. Okay, I need to see you work this. You know, this goes away, there's nothing. A positive 5 minus 5 is nothing. 6 minus 5 is 1. So x equals 1. If it's a subtraction equation, you do the opposite and add both sides. Need to see that. That goes away, you're left with 14. If it's a multiplication equation, you show it and you do division. 3 divided by 3 gives me a single 1x. But I have to do that to both sides. 18 divided by 3 is 6. And if it's division, you do the opposite and multiply both sides by 4, because when you do that, these cross cancel and you're left with 32. Now, the one exception to all of that, which isn't really an exception, but is if you see a fraction in front of a letter, if it's 1/2 x equals 10, how do I solve one that has a fraction in front? I flip and multiply both sides by that flipped fraction, because these would cross off, because you'd end up with 2 over 2, which is nothing more than 1. So you're left with an x, and 10 times 2 is 20. That would be your answer there. Now that's just review. Just review, kids. Today, what we're doing is we're actually taking and combining more than one type of equation. That's why it's going to take us 2 steps to solve it. For example, but the fundamental rules are the same. For example, if I have 2x minus 3 equals 15. 2x minus 3 is 15. This is a combination multiplication equation and subtraction equation. You know, we had multiplication up here and we had subtraction right here. Okay, so the rules are the same. You need to get x by itself. Okay, the one thing you have to remember, okay, so let me just review this here. I'm going to both divide and add to get my x by itself. Okay, but the rule is this. You always work with the term that does not have the letter with it first. In other words, the last thing I'm going to do is separate these two things. Okay, I want to get rid of the addition and subtraction stuff first. Okay, and to do that, it's just simply you think the opposite like we talked about there. I'm going to add 3 to both sides. A minus 3 plus 3, and they go away. I still have this 2x over here. I still have the equal sign. 15 plus 3 is 18. Okay, and then now, it's just like this multiplication equation here. I divide by both sides by 2. I get my x by itself, and x equals 9. And if you want to make sure that you did your problem right, we can go back to that original equation where it was 2x minus 3 equals 15. If I put 9 in for x, will it work out? 2 times 9 is 18. If I subtract 3 from 18, do I get 15 like I'm supposed to? I do. So this checks out. Okay, that checks out. Let me give you another one. How about 3x plus, well, 3x, yeah, I guess there's something more. If it is, let's say we have 3x plus 2 equals 17. Okay, following those simple rules we did before. Again, remember, the last thing you want to do is separate these two. So the first thing I do is the addition subtraction stuff. I'm going to subtract 2 from both sides, which means I get 3x, these goes away, equals 15. And then I'm going to divide by 3, x is going to equal 5. X is going to equal 5. Now, some things to watch out for. We got a couple extra little gizmo gadgets here to think about. In that is this, be very careful, because occasionally, every so often, you are going to have to deal with negatives and positives. So here, write down this example, negative 2x minus 5 equals 9. Okay, rules are still the same, except you just have to watch out when you multiply and divide integers by negatives and see what happens here. Let's talk about this. I want to get rid of the addition subtraction stuff first, so I add 5 to get rid of it, and I add 5 over here to get rid of it. It goes away, so I'm left with a minus 2x equals 14. Now here's kind of a new little twist here. Whatever is in front of the x is what I'm going to divide by. And I want my x always to be positive. So what I'm going to do is I need to divide by a negative 2. If there's a negative number in front of the x, you're going to divide by that negative with that number, because a negative times a negative, or negative divided by negative, makes a positive. So this goes away and I'm left with my x. But I also have to divide this by a negative 2. And if you look at your rules, a positive divided by a negative is going to give you a negative. One negative makes the whole thing negative, so it's x equals negative 7. X equals negative 7. So be careful with those positives and negatives. And the last thing that they're going to do, just because they like to, mess with you, they like to make it difficult. Check this one out. 3x plus 4. 3x plus 4 minus x equals 28. Now, what you might notice that's different that we haven't seen before is in every other case over here, we've only had 2 terms on this side of the equal sign. Okay. If you see this happen where there's 3 terms there, okay, what you're going to have to do before you do any of the moving things or adding and subtracting things from one side to the other is you need to add like terms. You need to add like terms. In other words, this. I can put together my 3x and my minus x. Okay, and don't get confused about this. I'm not doing the opposite. The only time I do the opposite is when I want to get rid of it and get it and do it to the other side. In other words, this. I have a 3x and I'm subtracting an x from it. They're already on the same side, so I can just put them together as they are. I don't change this to a positive and add it to that. If I were changing it to a positive, I would have to do it over here and add x over here. But I'm not. I'm just combining on the same side. A 3x minus an x gives me a 2x plus 4 equals 28. All right, now, once I've combined those like terms, now I can just subtract my 4. It's just like it was before. 28 minus 4 is 24. These go away. I'm left with 2x. I divide by 2. I divide by 2, and x is going to equal 12. X is going to equal 12. Let's see if I can find another example of that. You know what, we haven't really done a division equation. Let's do that. No, well, let's do one more of these. Let's say I have 5x minus 10 plus 3x equals 62. Okay, equals 62. And again, you realize there's a bunch of terms on this side, so I'm going to first, step number one, combine my x's. If I have 5 x's and 3 x's, that gives me a total of 8 x's. I'm going to rewrite what I have left. Now I want to get rid of the addition, subtraction stuff, so I add 10, I add 10, so now 8x is going to equal 72. I divide by 8, I divide both sides by 8, and I'm left with x equals 9. Just that easy, people. And again, remember, don't be doing all the stuff in your head. I need to see all of your work with these equations. It's not just about writing an answer down and saying, hey, look at me, I'm so smart, I got this right. I will then stop with that right there, 8th grade. I thank you for your undivided attention. I'm sure I will see you shortly.